So, on the previous video we saw how to make our units move on a path based on the grid we just made using the Pathfinder. Now we will see we're actually going to make the whole system more like XCOM. Okay, so that means when I'm clicking on a unit, I can see the path. Basically, we restrict his path based on the movement he can go on this turn. Okay, the blue is basically, if you haven't played the new XCOMs or something like the XCOM, there are a couple games that copy its mechanics. Okay, you have some nodes, the nodes that are close to you that are supposed to be the basic move. Okay, which if you move into one of these close nodes, you can actually also shoot into this in this turn. But if you move into nodes that are on the far, basically on the yellow, okay, then you cannot do pretty much anything else unless your character has a trait and stuff like that, which we're going to see a bit later. Now, we will not focus anything about multiple levels for right now. Okay, we will handle later the upper levels differently. We're only going to focus about 2D movement, and when I move and hit space, okay, it will go and recreate it. Now it doesn't matter, there is no turns just yet. Okay, and I can select the other guy and move and so on. And you will think that something as simple as this will take would be so hard to do, but we're actually going to do a lot of stuff, so let's not waste any more time and let's see. Okay, so on our level manager, we're going to add a game manager, which is the players and how many players we have on our list. Now, even if it's an AI player, okay, we also have to add it over here. The player interactions, we're going to do a few changes, and we're going to add a world UI manager, which is basically what turns the grid, the tiles of the grid. Okay, it makes them to change color and whatnot. And we're also going to make a new script on our unit prefab. Let's bring this over here, somewhere over here. Okay, which we're going to call unit node manager, and we're going to do a lot of changes. Let me delete this guy since I already have one. So let's start. Let's see the world UI manager. World UI manager. So, okay, keep in mind of the namespaces. We're also going to use the grid base, which is the grid master. We need the namespace of grid master, and we're going to use some stuff from the system namespace. A reference to our grid. Okay, we take it from the singleton. Now, basically, because we want to have, we do not just want to have, say, take 10 tiles or 10 nodes from each side. Okay, because it will basically make the movement too boxy to be so good. Okay, and it will not have it like this, like as a star. So we cannot just take the nodes we already have on our grid. We need to create another type of node where we will store the actual node on the grid, and we will also store the distance, the calculated distance, but not the distance calculated by the pathfinding, which I'm doing right now. Okay, the distance, the heuristic distance, basically the distance of each node from the starting node. But we do not want to pathfind for every node, actually call a pathfinding solution for this, okay, because it's going to be pretty much performant that way. So with a simple calculation in the distance of each node, we can get a result like this. And that's actually the one significant change XCOM has from other games, okay, and especially games like that work like this. So for instance, other games will have the movement over an obstacle, will have penalties and other stuff like that, but we're going to see on a different series all that. So we need to create a new class. Okay, movement node. Of course, the world UI manager is also a singleton, so we can access it from everywhere without having to resort to tags. Okay, so the new movement nodes we're going to need is, we need to pass the movement nodes of IQW movement nodes, and we have node actual, the node actual we have on our grid, and the distance from the target, from the starting node. Okay, and we have now this bool equals basically overrides the stuff the list by itself has. Okay, so when we call, if the return list contains a movement node, for this to be true, it comes over here and it passes the object for the contain, and it returns the solution for this. So it bases the comparison based on our custom properties we have over here. So we want to check if this list, which is a list of movement nodes, if already has a movement node that's equal to another node on the list, okay, we need some custom parameters over here. So instead of using a for loop for everything, which is also performant, then we need to we simply use this, which simply goes and checks for node actual. Okay, basically checks the x, the y, and the z, and that's why we need to derive from IQW, and you also need to pass the movement nodes, the class. Okay, so basically when we select a unit, okay, we need to start finding the nodes that we have he can walk around. So we come into this script and we go over here and we say find available movement nodes. We need to pass the states of the unit, so because on the states we have access to a lot of new parameters, and I'm going to put a bookmark over here and we're going to see the unit states. Now for the unit states we've added a lot more stuff. I've added reference to the unit controller and to the unit node manager, and I've also added two new classes, which is the unit stats and the unit rates. Now unit rates, we're not going to do anything with them in this video, but we'll see later how this will affect our whole game. Now unit stats is basically this could have been a different script, but we can also have it over here. It doesn't really matter. Okay, so the unit stats is, for right now, we'll have how many the distance between the basic move, the move that counts as one node, okay, the distance, or if the nodes are far away. So whenever I say close nodes, means the ones that count only as one move, and whenever I say far nodes, means the ones that count as two moves. Okay, and we also have them over here. So back on our World UI Manager, we need to find the distance from main. We basically want to find the maximum distance we want to use, and we're actually not gonna use a lot of it, this over here, so forget this one. Let's see, we have the list of movement nodes and we want to populate it, and we populate this with the call get neighbor nodes. Now this might have the same name as the Pathfinder, okay, but it's not exactly the same. Basically it's a different function. Might have the same name, but it's a different function, and it's this function. It takes the states. The DS is basically how many nodes we're gonna get from left to right. Basically we want a square. Think of it like that. So 10 will go -10 from 10 on all axes. So basically take a three-dimensional, think of it as a three-dimensional box, and we take nodes in it. And the other one we want to have, if we want to have on the Y, if we want to take positions on the Y or not. So we start with a list, and on the Pathfinder we had this from -1 to 1, but over here we want to have it as the DS. Basically DS stands for distance, of course. So we take all this stuff are the same as the Pathfinder, but instead of -1 and 1 we replace it with DS, and then we come over here. We still need to find what we're doing on the Pathfinder, which is take the current offset of the XYZ and add it onto our current node, but we basically do not have a starting node over here. The starting node will always be the current node the unit is upon. Okay, so we create a new search position and we find a node that is on there. Now if the node is null, okay, that means the position, we cannot go with that position or is out of the grid. So we need to check if it's not null and it's also walkable. We need to find the distance and between the current node, which is the node the unit is, and the node we have over here. And to find this get distance is an exact copy paste of what we have on the Pathfinder. Okay, and because if we're moving diagonally it will be 14, if we're moving straight or Manhattan way if you prefer, okay, the cost of that node is 10. So we return the distance, we find the distance of that node, and we say if the distance of that node is lower than the total distance our unit can move, okay, doesn't matter if it's on the close nodes or on the far nodes, then we create a new movement node, we update its values, and we pass the node we just made, and we pass also the distance we found over here, and we check if our return list contains another entry of this movement node, okay, that, and it compares it with this criteria, okay, and if it does not contain another one, then it adds it to the list. Now, why we have to do it this way is because we're creating a new movement node every time. Then that means it will never find a movement node to be the same. Okay. So this returns a list of movement node, and this is also a list, and we return this list. So basically, when we are searching for a list of movement nodes, we also want to keep store of the nodes we are changing, and we also want to return into that list. So basically, this return list will go into our unit node manager, where we have another movement node list, okay, and it will also store the movement nodes over here. And we do that because if I want to clear the node list, okay, I want to have the reference of the nodes we have used, and we can say that go change the tile material to none and clear this list. So when we are moving, moving from unit to unit, when I select one and I select the other one, then it deletes the previous, it deletes the tiles. Okay, it resets basically the renders and doesn't delete them exactly. Okay, so we can do this thing. Now, I didn't want to have each unit control its own tiles because it will have left stuff unchecked and it will be a total mess. So with this manager, basically it's what handles every time you want to change your grid, basically. So let's continue on. If I want to update the node status from the tile, basically, if I want to change the material on my tile renderer from blue to yellow to red to whatever, okay, I call these two functions, and these two functions go into the node we are passing, the node reference, which is, if you remember on the previous video, is what we hold all our materials, and say change tile material, we call that function, and we pass the target. Now, on the previous we were using a few integers. Right now we've created on a node reference, we created an enum, and we control with an enum basically what material to assign. Okay, this, we call this if we want to update only one node. We call this if we want to update a list of nodes. Okay, simple. Let's see the node references, and let me remove this one, this bookmark, and I'm actually going to, no, I'm going to keep it open. Let's see the node references. So what we changed over here is the function over here, and I've added the enum. So the enum is basically the materials we have, red, blue, yellow, and when the node is walkable, then I just simply have it to none because I simply disable the tile renderer. So on my change tile material, I pass the type I want, I enable the tile renderer so I do not have to copy paste it 3 times over here. Okay, it will always re-enable the tile renderer, and based on the type we have in our switch, it will change the tile materials, or it will simply disable the tile renderer. Okay, it's pretty simple, but it's a lot of stuff, so be careful to not confuse yourself. let's close this one. Unit states. We saw the updates we have over here, so I'm closing this. IK handler we're not going to use. Let's close the unit states, and let's see the unit controller. Or yes, let's see the unit controller. Let's see the unit controller first. So we make the unit controller, the unit states reference public, because we will access it from a different script, and you will see later. Okay, basically over here we have the same as before. We didn't change anything. And on update, now it only if I hit space, it will only update when the unit is selected. So it will only move on the path when the unit is selected. Okay, so when we are moving path, and I should have closed the unit states. Oops. Okay, so boolean, if the unit is selected, and if it has paths, and the other are on the unit node manager. So let's go back to unit controller, and we basically have, if we move on the path, we have I've put everything into their own functions, and their own functions are, okay, the update position variables, the first part of our lerp. The second part is exactly the same, but on its own variable, which is the handle movement and rotation, okay, which basically the lerp. And in between those, I have the new function which I'm calling find current node and update. Now, find current node, the only thing that it does is find the current node the unit is upon, and it calls a new function that we have, and it's called store references or node, and we pass the new node we are on, and it comes over here. It needs a reference to the previous node, so that we know where we previously were. Okay, so if the previous node is not null, that means we were moving from tile to tile, and we can check if the previous node is not the same as the target node. That means that we actually moved from node to node. Okay, if we are still on the same node, then we do not have to update any variables. So what we need to do is change the tile material of the previous node to none. So because we are moving from that node, that means that node is now walkable. So we make it walkable. The previous node unit of node will be null. Okay, and the previous node will be null. So we basically reset the previous node. Then we assign the new node to be unwalkable. We assigned the new node, the new unit or node will be our unit. Okay, so we have assigned our states, and then we change its material to red, and we assign on the previous node the new target node. So next time it will come, then it will run it again. It will check if we moved from node to node, and redo all these. But if the previous node is null, that means it's the first time we are on the initialization purposes. Okay, so that means we basically set it up like this. It's basically do the same, but ignore the previous node, since there is no previous node. And always on the state's current node will always be the previous node, okay, since it will always update to the target node. So that is basically the changes on the unit controller. Oops. Okay, those two are basically the lerp we have inside the update, but I've simply changed it. I've simply put them on their own functions to be more organized. And I'm going to put two bookmarks over here because we need to see first the unit node manager to understand all this. Okay, and everything else just stays pretty much the same in this script. So let's see the unit node manager. Now we need all these namespaces, and we're also going to include it on the unit control namespace. Okay, we need reference to our grid and to our state, and we need two public booleans, which if we are holding the path and if we are moving the path, if we have a moving path anyway. Distance from main, we need a list of movement nodes, which is the same from the World UI Manager, and we also need to separate which moves, which nodes are close nodes and which nodes are far nodes. And we also need a reference to our World UI Manager. We get the references, okay, on start, and we go into, after we get our unit states, we go into our unit states and assign the node manager. Okay, and we assign this for node manager, and then we get from the singletons, we get both grid base and World UI Manager. Now, on update, if the states says that this unit is selected, if we are not moving, if we do not have already a path, so that means we haven't yet calculated all the blue and yellow stuff over here. Okay, I select, and we haven't yet calculated all the stuff. Let's leave it open. And we're not holding the path. If we're holding the path, that means we're basically either moving or we just don't want to visualize the blue and yellow stuff. The first thing we need to do is clear all our list we have over here. Okay, just take all the lists and clear them. So we need to find the movement nodes we can move, and here's where the World UI Manager comes into play, and the find available movement nodes, this list. Okay, so let's put this over here. We populate our list of movement nodes with the function we call from the World UI Manager, and we of course pass our own states because it has variables we want to use. So this will return us all our movement nodes, but we want to separate them between close nodes and far nodes. So we have a for loop, and for each movement node we check the distance between the basic move distance we have on our stats. Okay, and if it belongs to the close nodes, just add them on the basic move nodes and update its node status, update it to have the blue material. Else, if it's not on the close nodes, that means it's on the far nodes, so add it on the list of double move nodes and change the material to yellow. We have a moving path, okay, because we have already found it. But if we are holding the path and we have at least one node into our movement nodes, then that means we want to clear the node list. So it comes over here into the World UI Manager and goes into every stored node we already have. It changes its material to be walkable, okay, because we are not taking unwalkable nodes into this list. And then we clear this list, and in turn we also clear, we probably should have do this too, although I'm not quite sure. Let's actually test it. Yeah, it works correctly from what I can see. Although I guess it doesn't really matter, since when this runs again it will always clear the list, but let's have it over there just to be sure. Okay, and basically the whole path is when I do this thing, okay, when I hit space and move, this runs the whole path, okay, because the unit is still selected, but I only want to remove the previous nodes we have stored. Now, if it's not selected, it will come over here, and if it has previously a moving path, then just go onto the World UI Manager and clear that node list. Okay, and then we do not have a moving path anymore. And that is the unit node manager. So, what left to do over here is the level initializer and the player interactions. And let's see the nodes too, just to be sure. Now, I don't remember if we had this on the previous video, but it's just a reference to the unit states. Okay, which unit is on this? Yeah, we probably didn't have this. This is only a reference to say on this node there is this unit. Okay, just think of it like that. So let's close this. Let's go to the level initializer. Now, to be sure that everything opens at the correct time and the references are always set up, okay, the World UI Manager will be in the same game object as the level manager, and it will also start as disabled. So we can come in here and into our coroutine that we are opening. We are creating the grid, we are creating the units and everything else. Okay, we can have a new coroutine, which is the enable world UI. And this coroutine is this one. It only takes the component of World UI Manager and it enables it, and it returns after the end of frame. Now, the other change I did over here is create units. So if we have more than one unit, instead of just instantiating it, okay, it stores it as a game object. It takes the unit controller component, and the starting position, it just multiplies the I by 3. Okay, it just places 3 tiles away from the starting position we already have on our unit. So if we want to create more than one unit, they do not all instantiate on the same node. So this is the level initializer. Let's close it. And let's actually see the game manager before we see the player interactions. Now basically what we need, game manager is something, a script basically that controls how many players we have on our current season. Now players can be a player with two users, basically a player and a player, actual players, and we're talking about something like local multiplayer. It could be player and AI, or it could be player and a simulation of a player, and that is for straight up multiplayer. So we have game manager, which also a singleton. Okay, wherever you see this, it's just the singleton. I like to keep it collapsed over there. Now we need a public class with a player base. We want to have a player ID. Basically every player has two things right now. It's player ID and its player type. Player type can be user, AI, or simulated. Simulated, I said what it is, it's for multiplayer. So we have a list of players. We want to have one active player. So we know which one's turn is. Okay, so which is the active player, whose turn is it? Think of it like that. We initialize the active player with the first one on the list. Okay, right now we only have one. And the other function we are going to use from the game manager right now is only compare ID with active player. We pass an ID. Okay, we initialize the return value with false, and if we have an active player and it's the active player's player ID is equals as the ID we're passing, the string we're passing, then the return value will be true. So that means what we clicked is actually a unit from the player that it actually plays. So you're basically selecting your own unit, and that is where the player IDs will come to play. But for right now, if you see on my game manager, I have my player list. Player ID, I just kept it empty because I only have one enemy. Okay, I only have one player. So for both of my units, player ID will be 0. If I change one to be, okay, it's a string. It doesn't have to be. You can write enemy over here. Now I do not know which one is. Probably this one. If I select my, and that didn't work. Yeah, it was this one. Yeah, it worked. Okay, I can select this guy because it did not belong to me, and later on we will see how to actually attack units and stuff like that. So for the game manager, that's only the only stuff we're going to use right now. Let's go into the player interactions. We need all that, as you can see. Okay, we saw some on the previous video. We need references, both Pathfinder, Grid Base, Game Manager, the World UI Manager, and we want to store the previous node our mouse was on. Okay, Visual Path, this all stuff stay the same. The active unit. Okay, so we have find unit or move unit. Previously we only have move unit, and we all had this stuff on update. So find unit. If we do not have an active unit and we click the mouse button, we need to find the node our unit our mouse clicked upon. Find node from mouse position. Okay, still the same, didn't change anything. And then we check if node is not null. Okay, if our node is not null, so that means we clicked on a node and that node has a unit upon it, so its unit or node is not null. We say go compare its player ID with the active player. So if it's true, if this returns true, then we have the active unit, and we say to that active unit, we assign the active unit, and we say to that active unit that your states, you are selected. Move unit, somewhat the same as before, but we found the start node and the target node. But before we go and check if it's null or not, over here we need to check if the target node is actually inside either on, it's not assigned into our list of closed nodes, and it's not assigned into our list of far nodes. Okay, so if the node is not into all of the nodes we can move on, then that means it's not a valid node and we cannot move there. Okay, so that makes it target node to null. So it basically nulls the target node, so this one never runs, so we do not request a path find. Okay, and we come over here and we say if previous node is not, if we have both of these are not null and it's not the same node as before and we are not holding the path, okay, then go and request a path find and it will do everything else. Now, previously we only have over here, we only had this one when we are clicking and we have an active unit to do to simply hold the path or unhold it. So we're going to change it, and we're actually going to still find the node the mouse was clicked upon, and if it has a unit, then it's going to go and compare if that unit belongs to us, and if it belongs to the active player, to us, okay, then it will say, it will check if the active unit, if the target unit we clicked is its controller, it's not the same as the active unit we have stored from the find unit, okay, and the unit we have over here, then that means we've clicked on a different unit. Okay, so that's basically we are selecting another unit that belongs to us. Okay, if we clicked again on the same unit we just selected, we do not want anything to happen. Okay, so we go into our World UI Manager and we clear all our previously saved nodes. Then on the active unit we have right now, we deselect it, we make it so that it's not selected. It does not have a moving path anymore, so the next time we're going to select it, it's going to recalculate all the previous stuff we saw, all the nodes it can move, and then the new active unit we assign as the target node. The new unit we clicked upon, we assign it as the new active unit. We make it selected, and we simply say that you do not have a moving path, but then in turn it's in its own unit node manager. It's going to go and recalculate all that, and it's going to make the has moving path to true. And that's a lot of stuff. So all the rest is the same. We didn't change anything. Okay, there was a lot of stuff to cover. Let me remove this one. Okay, keep in mind of the namespaces. And the only thing that we need to do is actually go back into the unit controller and explain where we use the node manager. Okay, on our unit states we have the unit node manager, and on our unit node manager, on start we go into our state and assign the unit node manager. So on unit controller we saw if we are moving on the path, then that means we want our node manager to stop showing the path that is the blue and yellow paths. Okay, the nodes we can move on. So we go in and change the whole path to true. If we are not moving on the path and the state manager was holding the path, it was holding to show the visualization of the nodes we can actually move, okay, then we want to make it to false. We basically reset the node manager to keep updating to visualize the nodes we previously had. And that's basically it, I believe. Yeah, I think we covered everything. So you see that something simple as that has a lot of stuff and a lot of work into it. Okay, now later on we're going to expand a lot more on this, and we're going to see to do a lot of changes. Now, a few things to keep track to note is that my basic move distance on my unit states and on my stats, my basic move distance is 50 and 50. Okay, but the nodes over here you see is I'm only saying take 10 nodes, 10 by 10. So it will take 20 nodes on the minus x to x. Okay, so it basically takes a box like this, but it will only take the nodes that are inside the move distance. Okay, and if you play with these values you will understand what I mean. Now later on, because we've basically hard-coded the, let me again find it, we basically hard-coded how many was it? It wasn't over here, it was over here. Yeah, we are hard coding the DS value we have on our get neighbors, okay, which is the DS, which stands for distance. But later on, where we advance more on stats, every unit can move, will be able to move based on its own stats instead of hard coding. So if a unit has a trait of fast runner, it can move further away than a unit that has a slow trait. Okay, and if I do, let's make it 5. You will see that when I select this one, it goes 5 by 5 and it makes a box. But since all the closed nodes are inside the distance we have onto our unit states, okay, then it looks like I can move into a box. Later on, when we are going to make this to be actually on an analogy between them, then we're going to make it look more better anyway. So I think I'm going to end this video right here. We've covered a lot of stuff, and there weren't actually so much interesting stuff, but they had to be done, so we are organized and how we can create our game. So if you ever thought that real-time games are harder to make than turn-based games, then think again. So we'll end this video over here. You know what to do. Like, subscribe, consider supporting me on Patreon or grabbing a project from Gumroad, and I'll see you next time.